Hey, so thank you all for joining us. So how many of you feel like are you familiar with IDEO? Like raise your hands. Pretty familiar. Okay, great. How familiar are you with blockchains? Hands up. Okay. So if you said like no to both of those, we're gonna do like really quick intro, so don't worry about it. Thank you for coming. We're gonna talk about human-centered design. We are a human-centered design firm, and that means that we tend to look at things through three different lenses. So we look at them through kind of the human lens of desirability, we look at them through the technical lens of feasibility, and we look through the business lens of viability. And so as a human-centered design firm, we start with the human element of desirability, except in the CoLab, where we start with the technology first. So we focus on emerging technology and understanding how it can fit into people's lives and solve problems for them and meet their needs, their desires. So we do this in collaboration with a whole host of partners. And they're not even all on this slide. We work with about 15 corporate partners who come and actually sit with us and participate in prototyping sprints 4 times a year, where we're collaboratively building prototypes to better understand blockchains and other emerging technologies. We also work with various academic institutions and recruit fellows from those institutions. And we have a lot of partners in the startup space who are doing cool things with blockchain technology. So let's talk about blockchains. What are blockchains? Well, blockchains are the technology behind Bitcoin, which was the first peer-to-peer decentralized digital currency. Now, what makes Bitcoin different? It's that it allowed, for the first time, value to be moved rather than just copied in a digital form. So think about how things work in a digital world, right? If I send you a photograph or a song or a PDF, I still have a perfect copy of the original. I can make 1 million copies, send them to 1 million people, and I still have the original. And that's great. That's done amazing things, right? It's enabled all sorts of new kind of media and forms of expression and communication, but it's not great for money, right? If I can copy a $20 bill and send it out 1 million times, and I still have my $20 bill, pretty soon money is going to be worthless. So the ability to digitally transfer something rather than just copying it is a really big breakthrough. So Bitcoin does this through the use of a blockchain or a distributed ledger. And there's a kind of fancy description here. The really simple one that I want you to focus on if you're like, I don't really know what a blockchain is, it's a database that we all agree on that is, it is append only. You can add things, but you can't go back and change things. So it's immutable in that sense. And it's got line by line permissioning. So you can only change entries that you have permission to. Right? So I can't update your account, I can only update my account. So given that this is a little bit different from what we've seen in the world before, how do we think about designing for blockchains, assuming that they will become relatively ubiquitous? And when I'm talking about design, I'm not just talking about user interfaces, I'm really talking about trust and how we guide users to understand how things are different when they're interacting with blockchains than when they're interacting with other services that they're already very used to, right? There's a lot of expectations that we've built up over decades of interaction in digital context where paradigms that we're used to may no longer be true when you bring a blockchain into the mix. So one of those is the idea of kind of permanence and irreversibility. So little Calvin and Hobbes comic, right? If you have bread and you make toast, you can't go back to bread. You now just have toast, right? So that's immutable. You can't like reverse this. There is no control Z when it comes to blockchains, right? So if you're used to like using kind of the undo send feature in Gmail, stuff like that, like you can't undo stuff. So you have to be really careful and make sure that you are doing what you mean to be doing. So let's say I want to send my friend Jesse some Bitcoin, for Jesse's birthday. And I'm like, okay, here's, a very generous birthday present. And I hit send, and then I get a message back. It's like, hey, Chris, I didn't get anything, but here's my address. So I sent to some random person's address because there's actually a difference here, right? So you have to be very careful and make sure that you're actually sending where you thought that you were going to be sending. You're missing the amount, right? If I meant to put like 0.001 Bitcoin and I send 0.1 Bitcoin, it's up to the person I send it to give it back. I can't call the credit card company and be like, hey, that was an accident or something. Can you send it back? It doesn't work that way with a blockchain. What's a context, though, where it's really desirable, right, to have this permanence, this irreversibility? This is a prototype that was built in the CoLab by some fellows, actually, I think in about 3 days. We call it the Glock chain. And the idea, the idea here is these were guns for law enforcement officers. And the idea here is that every time it is unholstered or the trigger is pulled, it registers that on the Ethereum blockchain publicly. So it puts a record of the gun being drawn or a shot being fired on an immutable public database. Now, law enforcement officers are already required to report when either of those actions happen. So this can actually automate the process and also create more trust that the reports that are coming out, like nothing is being hidden, it's not being changed. The core kind of details around that event are getting logged. So this we thought was a nice provocation in terms of places where immutability and permanence can be really seen as valuable. So to sum it up, permanence or reversibility, it's scary, but it enables us to do new things. So continuing on that is the idea of key management. And I'm not talking about house keys, I'm talking about cryptographic keys. So usually you're talking about like 30 some odd strings of like random characters that you use to generate digital signatures. They're kind of like passwords in that you want to keep them private, but you can't like reset them, and there's no one who can help you with that. So the first rule is don't lose your keys, and the second rule is don't let anybody else get your keys, because if they do, they have all the assets that are associated with those keys. So again, here's the example, right? We're used to the idea of password recovery. You forget your password, you can recover it, the service can help you with that, reset it. That is not true when you're dealing with private keys. So how do you manage this? There's a number of different approaches that can help users in different ways. So the first is we can go back to a bank-like service, like Coinbase, that can actually manage your keys for you. That's one option, but it's kind of going back to old paradigms rather than pushing some new ones. The next is MetaMask. So this is a browser extension that actually kind of manages the keys, helps you use them in the browser in context, but that keeps them locally on your machine. Then you can go to, it's a ledger wallet, so it's a dedicated hardware device, right? So it's air-gapped, it's not connected to the internet directly. You'd have to like connect it by wire. It's got a secure place to sign transactions with the keys. So that's one way. So it's again going back to kind of calling back as designers, thinking what people used to. We're used to keeping these physical things safe. So that's when we can do it. Or if we want to go really old school, you can actually just write down a passphrase or the key itself and just put it on a piece of paper, stick it in a vault somewhere so that it's safe. We've had, as humans, we've had like tens of thousands of years of practice of keeping physical things secure, and we've had just decades to learn how to try to keep digital things secure, and we're really not good at that yet. So if you really want to keep your keys secure for high-value stuff in a blockchain-based world, you're probably reverting to a physical form factor in some context. But for some that we want to use more actively, you're going to need to expose it to a computer on a fairly regular basis. So don't lose them, but they're going to allow us to have new kinds of privacy and convenience. One of the ways that manifests itself is when we talk about identity. So you go to a website and for the first time, you've got to put in your email address, create a password. Hopefully it's not the same password used on every other website, but it probably is. The nice thing is keys can act as a form of identity authentication across different services. So it means you can bring your identity with you, right? You don't have to create a new identity on every service. You can actually So it makes your identity kind of interoperable across these different services. This is one example. Augur is a decentralized application. It's a prediction market, so you can place wagers on the outcome of various events, finance, sports, politics, the weather, whatever you want. But it's a decentralized protocol. There is not a company with servers that you can just have them like log you in. You need to bring your own keys, bring your own identity to this context using various services that they support. So this seems kind of like Facebook Connect, right? It's like you can just go there and use the same identity across. What's different is you actually control the keys, you own your identity, as opposed to Facebook, which Facebook owns your identity. If they decide to shut down your account, you're out of luck. And then you're kind of locked out of services, or you're gonna have a really difficult time using all these different services that you've been using Facebook Connect to help you log into. You also have to worry about Facebook collecting data on you and knowing every time you're interacting with any of these services where you're using Facebook to log in. Here, if you use keys that you control, then you're the only one who needs to know that you're interacting with these services. So if we're using keys for identity purposes, what does that mean for privacy and transparency? Because remember, we've talked about the fact that blockchains are these public shared ledgers. You can verify information, and it's immutable. But do you really want a lot of information about your identity, about your activities, going in a public place, right? Probably there's some things you're okay with, but a lot of things you're not. So on the positive side, right, you can prove what you have and where it went. So think about one example, Bernie Madoff, right? We did not collectively, right? People who were investing in Bernie Madoff did not do a good job making sure that he actually had the assets that he said that he had. With blockchain-based assets, the person who, when they say like, oh, I've got so many assets, you say, prove it. And they can actually prove they do control the assets they say they control. They can prove they took the actions. You can verify that. And you don't even have to trust them. You can verify for yourself that they do have the assets that they said they had. Think about a nonprofit, right? That they can, if they're using blockchain-based payments, you can actually show that, okay, I can see where the money was going, how it was spent. And you can actually verify that it was being used for the purpose it was supposedly being used for. Then there's the flip side of transparency, which is privacy, right? If you are a business, if you're an investment manager, you don't want all of those activities being public to everyone, right? If you're a nonprofit, you maybe don't want the individual salaries of your employees to be public information. So we want to have some degree of privacy while also having that verifiability. So there are a number of things that we can do to help fix that situation. One of these is something called a zero knowledge proof. And it's being used in one place, most notably, by a currency called Zcash. So there's like really fancy math, but basically what zero knowledge proofs enable is I can prove to you that I know some piece of information without revealing that information to you. I can prove the information that is contained here is, that it says my birth date is such that I'm over 21 without revealing the exact birth date, right? We can do proofs like that where you're sharing the relevant information, but maybe not all the details, and only revealing the details to people for whom they actually have a reason to see the exact information. So these are all collectively some really kind of different design challenges than we may interact with in other settings. So as designers, it's our responsibility to think about the people that are using these applications, that are interacting with blockchains in various ways, and help them understand these new paradigms. So I'm going to walk through a really quick example that we actually discovered while we were putting together this presentation. So here is an example. Protecting someone, there's like this Bitcoin wiki page, and it's got an example of a private key. And you can see up there's the private key. But if you copy and paste it, it doesn't paste the same private key. It actually appends, sample private key, do not import. That's because there were a lot of people who were going to this wiki and they were seeing, oh, here's a private key. Oh, I'm going to trust me. I'll just use this as my private key. Problem is, it's a public private key. So as soon as they sent any money there, immediately somebody else was like taking their money. So people were losing money. good design thinking got a solution in place that would have an extra barrier, extra layer of friction, and realize, oh, maybe I should be doing that. So yeah, here's what's going on in the back end, right? They just kind of changed the HTML, what was happening here. So pretty simple, pretty effective. That's the kind of thinking that we need in this space. Because of that kind of irreversible paradigm, you don't want people to make a mistake that they can't undo, can't get back. So it's kind of a host of questions that I would pose that we really important to think about along with these themes, right? How can we help people know, how might we help them know that they're going to take an action that's irreversible, as in the case of the keys? How might we learn and follow best practices for keeping keys safe? Understand how identity is working differently with blockchains, and really think about it in the context of transparency and privacy. When can we verify information? When should we teach people to do that verification? And how can we help them preserve their privacy, or at least be aware when they're maybe making information public that they didn't want to? So that's the talk today. Now we're gonna kind of open it up for you guys to ask questions, and we'll also take some questions, I think, from Twitter as well. So, yeah.